Okay, my mic was off. Hello, CSEC scholars. Welcome to another live CSEC class. We're continuing with sets and we're starting very late tonight. Let me apologize for that. I've just been extremely busy since this evening. We're going to see how much we can do for tonight. We're still having our sets class, right? Let's see how much we can do within the time that we have left. So we're gonna get right into it. And before I do that, as usual, I want to play the schedule of live classes. We have 6 live CSEC classes per week. So here we go. Hello, CSEC math students. I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake, or you have, as thousands of other students have? Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything. Make sure you watch every series so that you can avoid making those mistakes. So stay tuned. Hello, scholars. Did you know that most times when students get problems wrong in mathematics as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. We know the errors beforehand, we can certainly avoid making them. Are you ready? Take my hand. All right, scholars, so we're going to get into it. I'm going to invite my studio crew to join me on the screen. Welcome Imani and John and Amari.
Night, miss.
Welcome Drayshawn. Come to your mic, sir. Mic check. All right, so we're still on sets, and we're going to be doing one or two. Yes, I'm hearing you now, Drayshawn. We're going to be looking at one or two CSEC past paper questions on sets dug up from many, many years ago. So let's take our time and see how we can go through these. All right. Can you see the screen? Oh, I have not shared the screen. Hold on. I have been up and down since evening. I am so disoriented. It's not even funny. It's not even funny right now. So bear with me tonight. Can you see the screen now?
Miss, it's loading. Yes, miss.
This is slow. Oh,
Can you read it?
no, Miss is coming
Yes,
out with the
miss. I can read
Oh,
it.
Make it
excellent. Yes,
or
please.
read it for me, Imani.
Okay, miss. Number 2. A, B, and C are three sets such that C is a subset of B, and the number in the universal set equals A union B union C equals 58. The number in B union C is 35, and the number in B intersect C is 22. The number in A intersect C is 10, and the number in A is 40, and the number in B complement is 23. U represents the universal set. Draw a Venn diagram to represent the above information and hence determine the number in B intersect A intersect C complement.
Okay. Read it again.
Okay, miss. Number 2. A, B, and C are three sets that C is a subset of B, and the number in the universal set equals the number in A union B union C, which is 58. The number in B union C is 35. The number in B intersect C is 22. The number in A intersect C is 10. The number in A is 40, and the number in B complement is 23. U represents the universal set. Draw a Venn diagram to represent the above information and hence determine the number in B intersect A intersect C complement.
All right. So what we're going to do? What we're going to do for that?
Um, Miss,
Trying.
so
I'm gonna try and get it. Gonna try and get it.
why
So
the
you can just give me a second. I'm gonna try and get it so you can see better. And this one. So in the meantime, think about it.
okay, miss.
All right. So kind of put it here. I'm trying all kind of madness. so, so I'm kind of taking it out of the way so that we can have space to work it. All right. So this was a 1996 question.
It's
So
1986.
1980s. What did I say?
Miss 1996.
1996.
I'm
That's
telling us I'm
really.
disoriented this evening, though.
Yes, miss.
Totally disoriented. All right. So A, B, and
Miss,
C are three sets such that C is a subset of B, and the number in the universal set is equal to the number in A union B union C, which is 58. The number in B union C is 35. The number in B intersect C is 22. And the number in A intersect C is 10. The number in A is 40. And the number in B complement is 23. So U represents the universal set. Draw a Venn diagram to represent the above information and hence determine the number in B intersect A intersect C complement. All right, how we're going to do this now, guys? How
okay.
we're going to do this? So it's how many sets? Three
Miss,
sets.
yes, miss.
Yes,
Okay.
miss.
How are we going to draw them? Are we going to draw them with the three sets intersecting? Let me draw an example of what I'm saying. Three ideas. So are we gonna draw them like this? We can draw three sets intersecting like that, right?
Okay, you see what Miss doing?
Or are we gonna draw them like this? Or are we gonna draw them something more like that? And then something like that.
Miss,
So
I'm
read
going
it
to that.
carefully. Huh?
Miss, I had the last one.
The last
Just
one.
yes,
And
miss.
could it be the last
Something
one?
closer to the last one, right?
Yes,
Yes,
miss.
please.
What you said, Rayshon and John?
Miss, I would go with the first
Read
one.
what the first one,
Yes, miss.
Rayshon,
Miss, wouldn't it
based on
be
what they're
C?
saying about
Miss, wouldn't it
hmm?
be something like C?
Something. Why do you say C?
Miss,
Miss,
because
because C is a subset of B and
yes,
it would
miss.
be within B.
Miss, it
Okay,
would be
so
the
because
C,
it
miss.
says one of the sets is a
Miss, one of them is
subset
a subset of the
of the
other.
other, so it will be more the C one. Okay, so erase them, but so B is a subset of A. B is a where is that? C is a subset of B. Sorry.
Subset of B. Yes, miss.
Okay. C is a subset of B, but all three sets do intersect though. All three sets intersect. So even though C is a subset of B, we still have to go draw the other set A so that it overlap the two of them, right?
Yes, miss.
So it's similar to C, but this one we have to come over some more into this. So let me draw them. So we're going to have
Hey, miss.
yeah. All right. So let's draw the Venn diagram, the rectangle. All right. So that's gonna pass as a rectangle once no one has any complaints. And our universal set, so that is gonna be 58. Universal set 58. Now we have to draw. So C is contained within B. C is a subset of B. All right. So that is C, and that is B. Everything is in B, but A also cuts into B and C. A also cuts into B. So we're gonna carry A. A cuts into C, so it automatically cuts into B, right?
Yes, miss.
So A is something like that. Let's try. So that's A. This
Miss,
is
that's kind of
C,
weird.
which is the subset,
Yes, miss.
and that's B, right?
Yes, miss.
Yes,
All
miss.
right. Okay, now. So let's see now. So all of them combined is so A union B union C is 58. That means there's nothing on the outside here, don't it?
No, no, miss. There's nothing on the outside.
Because it's either in A or B or C. There's nothing, there's no union of these, there's no complement of the unions. All right, so we know said nothing no out here. So everything in these three sets must add up to the 58. So let's see what they tell us. The number in B union C is 35. And the number in B intersects C is 22. So where are we going to put the 35 and the 22?
Miss 35 will go in A. Oh, wait, sorry, Miss B Union C.
Where on the diagram am I going to put
Miss where B
35?
and C, Miss where B is a subset, where C is a subset of B. Oh, Miss, you mean like it's, Miss like inside? Miss, I don't know.
So
Somewhere,
remember, since everything in C is contained within B, right? Remember the rule that says if A is a subset of B, then A intersect B is there. A intersect B is A, and A union B is B.
oh, okay.
Remember that law?
Yes,
If
Miss,
A
I
is a subset of B, A intersect B is all of A, and A union B is all of B.
yes,
So
Miss,
since
so,
B is C is a subset, and C has 22. So for the time being, let's put 22 here to represent all of C, right?
okay.
So if all of
Okay.
C is 22 and B is 35, that means the rest of B is how much?
Miss, the rest of B would be, Miss, it would be 13.
The rest of B would be 13. All right, so for the time being, let's put 13 here for the rest of B. Okay. I will know C is 22. But A intersects C is 10. So where A come over into C
Yes,
here,
it, yes, Miss, it would
this
be
part here is
intersection.
10.
Yes,
Don't?
yes, Miss.
So that mean what leave back out of the C would be 12. You follow?
Yes, Miss.
Because all of C is 22. So if A intersects C is 10, so what left back in this part of C is 12. All right, so what else they say now? The number in A is 40. So let's put a 40 there. Number in A is 40. Number
And the
in
number
B.
in B complement is 23.
So the number that's not in B at all. So B complement is 23. So that would be here, though.
Yes, Miss.
This is the only part of the graph that's not in B. So this
Yes,
is 23. So if all of A is 40, and this is 10, and that is 23, how much that add up to?
33 Miss.
33? That
Yes,
means this
Miss.
Thirty.
is 7.
Yes,
No.
Miss. Yes, Miss.
And that means if this is 7 and here was 13, so we can take out the 13 and put 6 here. So,
Yes, Miss.
so
Miss, how would
let's remove this 13. If we take
Miss.
7 out of the 13,
Yes, Miss.
so we're left with 6 in B only, right?
Yes,
B
Miss.
only would be 6. All right. Anything else they want us to fill in? Let me see.
No, no, Miss.
Now they want to know what is B intersect A intersect C complement. So in other words, they want to know what is in the intersection of B and A, not what includes C.
Miss 7? Miss will be 7?
Right. So it will be the 7. You see that?
Yes, Miss.
7. So we have deduced We have deduced from what they gave us. And let's see if everything in here now adds up to the 58.
Okay.
So add up for me. 23 plus 7 is what? 30. Why I keep
Miss
doing
30.
30, 40, 52,
52.
50,
Yes.
58, right?
80. Yes, miss.
Okay. All right. So for those who are still trying to figure it out, those in the audience still trying to figure it out. So let's see now. So we said there are A, B, and C, 3 sets, such that C is a subset of B, and the number in the universal set is A union B union C equal 58. So what this is telling us is there is nothing on the outside in the rectangle here. Everything that make up the 58 is within the 3 circles. The number in B union C is 35, and the number in B intersect C is 22. So the law of subsets, I like to call it the law of subsets. It says if A is a subset of B, then their intersection is A and their union is B. So here we have C is a subset of B. So their union is equal to set C. Their intersection is equal to set C, and their union is equal to set B. Therefore, since their intersection is 22, so set C is 22, and their union is 35, that's set B, right in here now would have been the 22, the 35 minus 22, which is 13. So that's why we had a 13 here originally. That would represent here. Then now they're telling us that A intersects C. So A comes over. Once it intersects C, it automatically going to intersect B because C is within B. So where A intersects C, that's 10. And there are 40 things in A and 23 things that are not in B. This represents what's not in B. So we take that out of the 40. Remember, we had a 10 here. So that means right here is 7. And we take the 7 out of the 13. So we get that out here is 6. And the question asks us to find B intersects A. So that's all of these two are B intersect A. These two are B intersect A, but they don't want the part that's intersect with C. So that's why we cut off this part now. And this is the answer. All right, so next question. So I'm gonna have to do like what I did a while ago and cut it up. So this was from June 1987. Before I let you read it, I'm going to
Oh, that's so
dissect it.
old. They're so old.
It's what?
Yes, they're really old.
Yeah, they're old, much older.
Yes.
That's how long CXC has been tormenting students. All right, so let me cut this one now and take off the top. We stop at school. Yeah, these questions are all right. So no, this one first. That one first. I may enlarge them a little bit. All right, so Dreshan, you going to read this one for me. Go ahead. Can you see?
Oh, I must have pressed the unmute button. I thought I was unmuted. But yes, Miss, I can
Okay.
see.
All right, go
U
ahead.
is equal to U is equal to class of 36 students. W equal 15 pupils who walk to school. R equals 18 pupils who ride to school. L equal 20 pupils who lunch at school. All the pupils who neither walk nor ride to school have their lunch at school. 10 of the pupils who walk and 7 of the pupils who ride have their lunch at school. Draw a Venn diagram to represent the information. Indicate clearly the number of elements of each set and subset.
Okay, read it again.
Number 3. U is equal to class of 36 pupils. W equal 15, 15 pupils who walk to school. R is equal to 18 pupils who ride to school. L is equal to 20 pupils who lunch at school. All the pupils who neither walk nor ride to school have their lunch at school. 10 of the pupils who walk, and 7 of the pupils who ride leave their lunch at school. Draw a Venn diagram to represent this information. Indicate clearly the number of elements of each set and subset.
Okay, before we go further, let me just big up the crew in the chat. Vanessa, welcome. Tasha, welcome. Young DK, as usual, welcome. Carlos Surf, I hope I'm pronouncing your name properly, Carlos. Welcome, everyone. We're always happy to have you with us. And feel free to drop your comments and ask your questions. All right, scholars in studio, let's see now. Again, we're dealing with how many sets? How many
This
sets?
3. This 3.
So let me draw the options. Is it gonna be this? Why you wanna flop my show? Why you wanna flop my show? All right, so did that. Something like that. Or is it gonna be this? Or something like what we just did where we had intersection and something coming over into which one of them is big based on this information here. All the pupils who neither walk nor have their lunch at school. Which one of the options we're gonna use for the 3 sets? Ideas? Let me hear your ideas, guys. Which of those 3? Imani, what you say? Uda, Imani? Imagine wrong with your mic?
No, miss, I'm rereading the question. Okay.
So you read it over. Because it's very important to know which of those we choose to represent. Is there anything in there that indicates that we're dealing with subsets?
Nope.
Mm-mm.
Wait, miss. Drop in diagram
Tell
to
us
represent this information.
that
indicate the number of yes, miss. Miss the
All
number
the
of elements of
pupils.
each
Wait.
set and subset. Says subset. See,
All the pupils who neither walk nor ride to school have their lunch at school.
Subset.
yes, miss. Miss in the last part where it says draw a Venn diagram to represent this information. Indicate
All
clearly.
ride.
Miss. Oh, miss.
Yes, miss, that's what I just said.
Miss, one of them indicates about subsets. Miss, indicate clearly the
Indicate
number of
clearly
elements of each set and
the ele-
subset and
and
subset.
subs, if any, if there are any.
Indicate. Oh yeah.
But is there anything there that tells us we're dealing with
Subset.
subsets?
No, miss, not really.
No.
No.
Is there anything?
Mm-mm.
No. So miss is just gonna be a disjoint.
All right. What does this here? The other pupils who neither walk nor ride have their lunch at school.
Miss, I think you would do the first one.
First one.
All the pupils
Right.
neither walk nor ride.
Alright. No.
All right. I think the middle one would be more appropriate. There are persons who neither walk nor ride.
Miss, what is the dub?
In other words,
Gotcha.
right. So there are persons who neither walk. So it's in part here. Right?
Oh, yes, miss.
Connecting thing.
Miss, right, be the
So
third one then.
we're going to put lunch in the middle. So let me erase these. All right, so so we're gonna draw our Venn diagram. As usual, it's a rectangle. All right, so we're gonna have walk, ride, lunch. So we're going to put lunch in the middle. So that's lunch. All right, we're going to put, let's put ride, and we're going to put walk. All right, what they're saying now. They say that 15 pupils walk. So the whole circle for walk must have 15. The universal set is 36. All right, 15 people walk, 18 ride, and 20 of them have lunch. All the pupils who neither walk nor ride have their lunch. All right, so 10 pupils walk. 10 pupils who walk and 7 who ride have lunch. All right, so 10 pupils who walk also have lunch. So that means 10 of these people who walk overlap with the lunch. So we're going to take 10 out of the 15 here. So the intersection of walk and lunch is 10. That means what is walk only? If all of the walk circle is 15 and 10 of them who walk have lunch, so this is 10. So how much is in here for walk only?
Miss 5.
Oh yeah, cause it's 20 from the
5.
15.
Okay. And 7 of those who have lunch. So this is 7.
Yes, Miss.
7 who
And that
want to
would
ride
be,
up.
yes, Miss, and
So
that
how
would
much
be
is it?
11. 11.
Just
So
11?
that's 11
How's it 11, miss?
Because 7 of the 18 eat
because
lunch.
18 people ride. So if we take out 7, so this is 11. Okay. All right. So what they want to know.
Miss, we're supposed
So we
to
need,
Miss,
follow
so how much is in here, so in here?
Miss Third, Miss 3.
yes, Miss.
Because it's 20 in all, and that's 10 and 7, 3. Is there any on the outside who neither walk, ride, or have lunch?
Miss T. No, Miss, there's none, Miss. Miss, because
How you know that?
Miss, because Miss, because
Miss,
I add them up.
because all of them who do not eat their lunch at school.
But Miss, I add up all the numbers, all the elements in the Venn diagram, Miss, and I got 36. 3 plus
Okay, so
7
the
give me 10,
a universal set is 36.
yes, Miss.
And as for
So
me,
when we
add them
add
up to get it.
11 plus 7 plus
18.
3 plus 10 plus 5. So all of these
Yes,
give 36, right?
yes, Miss.
So that's how we know there's nobody left back. If when we added up all of these, we got less than 36, we'll put the extra out here
Yes, Miss, because
somewhere else. Yeah,
what we
because
got
we
I
would
got
know that correct, right? So we would have to look back at the universal set, how much need to be in the universal set, and make sure that we get the amount in the sets here. Otherwise, we'd have to put the extra on the outside. So to recap what we did here, so they told us that there are 3 sets, and the first thing we did was to decide how we're going to display the sets. They didn't tell us that there was anybody who did all 3, right?
Mm.
They didn't indicate to us that there was a place where all 3 sets intersected. So we did not choose the one that looked like this. This is where you have a case where you have people who do all 3 and they would fall in here, right? We weren't told anything like that. We know that there are some who walk, some who ride, some who have lunch, and there are some who do neither walk nor ride and have lunch. So the 3 sets do not intersect in the middle. All right, so we decided to draw it like this then, because there are a number of ways you can draw 3 sets intersecting. So this is the one we chose. Since there are persons who walk and have lunch and ride and have lunch, so we put lunch in the middle. We put the lunch one in the middle. Then now we're going to decide how we allocate the numbers. So 10 persons, 10 persons who walk have lunch. So 10 out of the walk go in the intersection between walk and lunch. That means 5 left back because 15 people walk. 7 people who ride have lunch. So we put 7 in the intersection of ride and lunch. And since ride has 18, take the 7 out of 18, 11 leave back. And finally now to put how much is here for lunch only. So these people in here, they have lunch, but they don't walk or ride. So since lunch has to have 20, we add up the 10 and the 7, 17, take it from the 20, so in here is 3. So 3 people have lunch, but neither walk nor ride. And as John pointed out, since the universal set is 36, we are supposed to add all the numbers and get back 36, which we are able to do that. All right. So we're going to wrap it up there. We started very late this evening, and it's already after 9. So we're going to end there. When we're going to do another sets class, because I really want to do find missing numbers for 3 sets. We haven't done that yet. So we have more sets class to do next week before we go on to another topic. All right. Okay, guys. So it's late, and I know you guys have tests tomorrow. So I'm going to release you so you can go and rest.
Thank you.
And I will see you tomorrow. Okay, so good night for joining me. Those in the chat, thanks for joining me as well. I'll see you tomorrow.
Miss,
Alright.
Miss, if you got something, remember, we're not just solving math problems, we're changing lives.
Thank you, John. Not just solving math problems, we are changing lives. Absolutely are. All right, go and rest. Get some rest, money, and
Yes.
tell Amari to rest up. And see you tomorrow.
See you tomorrow, Miss.
Right.
Bye.
Bye. Hello, CSEC math students. I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem simply because of making one little mistake? I'm sure you have, as thousands of other students have. In this series, we're going to be looking at the common mistakes that students make on all the topics in CSEC math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello, scholars. Did you know that most times when students get problems wrong in mathematics it's as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the cause that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my